All right. So the last time we looked at probability, let me just remind you of the formula for probability. We looked at probability and we're able to consider this formula. Please, if you don't have this formula, write it down. Please write it down. Write this formula down. Write this formula down. What is this probability formula? The N is a number of successes in any sample. So you might call the sample size. The X is the very number that you are looking for. Sorry, the N is a sample size. The X is the number of successes in the sample. That is, out of that sample size, you might be looking for a particular number, and that one is the X. P is a probability of success. 1 minus P is a probability of failure. So note this. So let me just use this as a way to welcome you to look at a very simple example of situation that calls for binomial probability. One of the things you should look out for in any situation is to know the characteristics of binomial probability and use that to answer a binomial question. So let's take an example that will make sense. Suppose I flip a coin 4 times. Suppose I flip a coin 4 times and let X be head. Okay, I flip a coin 4 times. Let X be the number of heads. Now, anytime you have a situation like this, first you got to determine under what circumstances is this a binomial question. Because when you have a Poisson, which we shall come to, or a normal distribution, you got to distinguish them from binomial. So what makes this a binomial situation? Who can tell us? What makes this a binomial situation? And please have a book with you. Yes, Agnes.
There are 2 outcomes in the event, either heads or
Exactly.
tail.
Exactly. So you know that the outcomes are 2, head or tail. That's a clear indication that it's binomial. Now, once you get to know that this is binomial, the next thing you want to do is to identify the elements. First, you identify the N, the P, the 1 minus the P, and then the X. So in this question, what is N? What is N? Who can tell us what N is, the sample size? Just from this question, this statement. What is the N? Yes, who's bold? Flip a coin 4 times, let X be the number of heads. Livingstone.
N,
Yes.
N is 4.
N is 4. Okay, what is P? N is 4. What is P? You can tell us what P is. So N is 4. Esther.
P is 8.
P is 8. No. Remember, P is the probability of success.
Head, tail, tail, head, tail, tail, head.
I can't hear you at all.
Okay, so I'm working it out. Head, tail, tail, head, tail, tail.
Take your time. Take your time. You don't do it with us. Okay. I just want to know what is the probability of success. I mean, if you have seen any situation of binomial, because remember, you just indicated that there are only 2 outcomes. So what is the probability of success? In other words, what is the probability that there will be a head? And what is the probability that there would not be a head? That's all. Bernardine, now you got it.
I think 0, 1, 2, and 3.
Okay. So the probability of success is 0.5. Okay. The probability of success is 0.5 because the chances of you, getting ahead is 50%. The chances of you not getting ahead, sorry, is also 50%. Okay. So the probability of success is 0.5. You got to understand one thing about binomial is that you got to know the probability of the thing that the outcome. What is the probability of that very outcome? It's not the number of times you do the thing, okay, but that very outcome. And in this case, the toss of a coin is already a binomial situation, which is a 50. So the probability of success is 0.5. What is the probability of failure? Bernardine?
0.5.
Clearly, the probability of failure is also 0.5. Now, it says that let X be the number of heads. So you've been told what X is. So now we're looking for X. It says that let X be the number of heads. So what is the number of heads? If X is the number of heads, what will be that number of X? Remember, you flip the coin 4 times. You flip the coin. You flip the coin 4 times. So this is it. Okay? The number of heads is 0, 1, 2, 3, 4. Why? Okay, why? Why? Because the first possibility is that there will not be any head at all. That's the first possibility. And remember, he did it 4 times. The next possibility is that there could be 1 head in all of the 4, flips. Or there could be 2 heads. Yeah, remember, you're doing it 4 times. And in all 4 cases, there could be that, in all 4 cases, there's 4 heads. We did this thing before. We've done it before. So these are the probabilities. So now the question becomes, how do you now put this into the binomial formula? The chances. You got to calculate the probability that X is 0, the probability that X is 1, the probability that X is. So what is the probability that if I flip the coin, I'm going to, the moment you've realized that this is a binomial question, you got to use a binomial formula. Okay, so use a binomial formula. But of course, you're not going to do that yet. I just wanted to know your capability of determining that something is a binomial. Let's get to the real one. Okay, this one, you will get the idea as well. Yes, Bernardine. Your hand is up.
No, sorry, it's a mistake.
All right,
I think
let's
from
move on. Lower it. You just lower it.
Okay.
So here's another question. And again, I want you to have a pen and paper with you so that you know you are in the middle of the thick forest. What is the probability of 1 success in 5 observations if the probability of success is 0.1? Now, what clearly shows that this is a binomial question? What gives us a clue that this is binomial? There's some keywords. And in this very case, it's quite obvious. What shows that this is binomial question? Remember, one of the things about binomial is that the outcomes must be what? The outcomes must be what? How many outcomes? 2. Elizabeth?
2.
Okay. So what shows here that there are 2 outcomes?
Because we have a success observation.
Which means that we should have what?
A failure.
Good. So that's the first easy way to know that this is a probability. Your capability to determine that it's a binomial is critical to anything at all. Which is very important. Now that you've identified that it is binomial, then you expect those items. First, we need to find our n, we need to find our p, 1 minus p, and then we need to find our x. So in this case, what is our n? Our sample size. It's obvious. What is our sample size? What's I? Anita.
5.
N is 5. What is the probability of success? Anita.
Please, it was an old hand.
0.1. What is the probability of failure? Livingston. 0.9. What is the value of X? Read the question. It's right in front of you. What is the value of X?
1.
It's 1. So I want you guys to put this into the binomial formula and tell me the answer. Okay. Put this into the binomial formula and tell me the answer to this question. Who's done? You remember the formula? Okay. It is going to be P equal to X being equal to 1. P of X is equal to 1. Equals to, then you write the actual formula, which is N factorial divided by, do you guys remember that? X factorial into bracket N minus X, all factorial. Remember the rest? P raised to the power X, and then 1 minus P raised to the power, you remember? N minus X. This is it. Write it down. Eric, write it down.
Please, I'm getting 0.328.
Are you talking about your answer?
Yes, please.
Yeah, that's the correct answer. So guys, fit that into your calculator. You will use your calculator, fit that into your calculator, and then you get it. It is an easy thing to look at. You should know what an X factorial is. N factorial here, N is 5. So N factorial will be 5 times 4 times 3 times 2 times 1. Okay. And that is divided by X factorial. X is 1. So 1 factorial is what? What is 1 factorial? If you have a calculator, you would have done that. Do you guys have a calculator? Eric, you found the answer. How did you get it?
Yeah, so I used the same format you are using. So the 1 factorial is 1.
Okay. And N minus 1, that is 5 minus 1 is 4.
Yes.
So you have 4 by 3 by 2 by 1. Okay. And then the rest is 0.5 raised to the power 1, and then 0.9 raised to the power 4. You substitute all of that. Because these ones will cancel this. Okay. So you are left with 5. I want to multiply the 5 by the probabilities and the exponents. That will give you a very beautiful answer that my good friend mentioned. He says 0.3805. This is how you find it. Would you have been able to find this under some sort of intense pressure? Detect that is a binomial. Identify the elements of the binomial formula. Check how you find each element. Your job is done. Your job is done. Let's take another example. So what is the probability of getting exactly 2 tails in 3 tosses of a coin? Is this binomial or Poisson? Of course, I'm going to ask you why. Is this binomial or Poisson? Don't worry, I'll show you how to determine it. But is this binomial or Poisson on top of your head? Eric, are you there?
Yes, sir, please, I'm here.
You didn't know the answer to this question I just asked, right?
I was thinking the
No, I'm
binomial.
asking whether you didn't know.
You were asking whether I didn't know.
You know, did you have an idea of the answer to the question?
Yeah, so in my mind, I was thinking it was a
Don't
binomial.
worry, I didn't say give me the answer. I'm asking whether you had an idea.
Yes, please, I did.
Okay, that's it. Livingstone, are you around? Anita, are you there?
Yes, please, I'm here.
Did you have an
Yes.
idea of the answer to the question?
I think so.
Okay. Livingstone. I'm sure he will say, what the reason why I'm asking you these things are if you have an idea, it's your responsibility to raise your hand to help your colleagues. Okay. Other than that, I am tempted to give all of the answers and then move faster, forgetting myself. I won't lie to you. So it's very important that if you have an idea, you share that idea. That's how you help yourself and help other people. Remember, there's more happiness in giving. All right. So the key words here that guide you to know that this is a true binomial question is the fact that we are dealing with toss of a coin. So that's the main thing. That's what gives us a clue. Now that we know it's binomial, we need to identify the n, the p, the 1 minus the p, and then the x. What is the probability of getting exactly 2 tails in 3 tosses? So n is what? Eric.
Please, 3.
N is 3. What is P? What is
P
P?
is 0.5.
Exactly, because you are still tossing a coin. Okay, so 0.5. Now, regarding the X, you have to sometimes reach further. So the question is, so we identified all of the elements. So let's go to the X. In this question, you will notice that X is what? X is what?
I think it's 2.
It's 2.
2.
That's it. So X is 2. So you now substitute all of that into the binomial formula. I mean, substituting them into the formula is not a problem. The key is finding what is what. So let's do that. Substitute that here and put that into the binomial formula. And you're going to get 2. Remember, it says exactly. So that means that you want equal to 2. Okay. So probability is X is equal to 2. And you can now calculate the answer. And you will notice you got to sit down and do this. Okay, that you're going to get 35.5%. So the chances of getting exactly 2 tails, if you throw the coin 3 times, the chances of getting 2 tails is 37.5%. That's it. So far, we've been dealing with coins. Let's go here. Example is more efficacious than precept. So I'm trying to give you as many examples as possible. The most important thing is your ability, the ability to detect whether it's binomial or Poisson. So somebody should please read the thing for us. Somebody should read the thing for us. Who can do the reading?
Hi, Sense Ghana.
Yeah, Abigail, go ahead.
Hisense Ghana produces and sells HD TVs. The HD TVs are inspected at the end of the production process at a quality control station. Out of every batch of HD TVs, 4 are randomly selected and tested for defects. Given that 20% of all batches are defective, what is the probability that each batch of HD TVs will contain exactly 2 defective HD TVs? Is this binomial? Question mark.
Good. All right. So what shows that this is not a Poisson but is binomial? Guys, I won't lie to you, your capacity to distinguish if it was not under binomial you're doing it, is you got to have this clear sense of distinguishing between the two. Yes, Eliza.
Sir, because any TV that's selected can be either defective or not defective.
Good. So it's a level of defects. That's what. So there are 2 outcomes. Always look for that. What are the outcomes? In this case, defective or not defective. Okay. Now we've got to identify the N, the P, the 1 minus the P, and then the X. So what is a sample size here? This is quite tricky, but it's also cool. This is very practical as well. So try and understand the story here. The story is that there are a lot of HD TVs here. Every year, at the end of the year, there's a check. Quality control coming to the company, check whether the consignment that they have, whether there's an issue or not. And out of every batch, 4 are selected, tested for defects. 20% of all the badges are usually defective. Usually, generally, previously, historically. So what is N? Now let's see. Elizabeth.
N is 4.
According to you, N is 4. Okay. What is P? Magdalene.
0.8.
P. No. And I know why you said 0.8. Elizabeth.
0.2.
Why is it 0.2 and not 0.8?
Because it says given that 20% of all the badges are defective. So with the 20%, the probability of success defective. So the probability of success is the defective item. And so the probability.
Okay. That's all I need.
Okay.
The probability of success is a defective item. Going back to you, Magdalene. You see, you are not saying that because success is good, then the thing must be non-defective one. No. But then the success here is what you are looking for. The success. So if you enter a place and I'm saying that I'm looking for all those that have cancer, then the success is those that have cancer. It doesn't mean that it got to be good because of the word success. Darling, do you get a picture?
Yes, please. Yes, please. Thank you.
So that is 0.8. And now we are looking for X. So what is the value of X? Eric.
Please, I think it's 2.
It is 2.
Sorry, it's 4.
Hey, I thought you said it's 2 and I gave you correct. Now you switch it to it's 4.
Yeah, so I was looking at the 4 HD
4 has
TV.
already been used. And if you were following, you will notice that your colleague said that that is a sample size. Livingston.
Oh yeah, sorry, 2.
No, you are guessing. Because it's not 4, it's 2 by force. But I want you to understand. It's not choosing answers. Yeah, Livingston.
Says it's 2.
Why? Why is it 2?
So we are looking at defective and non-defective.
Why is 2? Why is it 2? Remember, that X is always the number of successes. The number of successes. And 2 is the number of successes. 2 is the one that is representing the defective items. But if you look at the 4, the 4 is a random sample of items to test for the defect. So the 4, you don't know which one of them is defective yet. Out of that 4, that number of success, those that are defective, that is the 2. Okay. Now that you have the answer, what do? You see, at this stage, you just substitute them into the formula and then calculate it. So when you substitute it in the formula, you will notice your answer. Okay. So you find your answer this way. And again, just go and substitute. And you will know that the chances of you getting 2 out of the 4 being defective is 15% on average. 50%. That's the chances of you getting, 2 out of the 4 to be defective. Remember that historically, normally 20%. But in this very example, because of the probability of success here, okay, because of the probability of success, that's it. Okay. Now watch it. It said exactly 2. It didn't say more than 2. So it's very important to bring in words like that. Okay, exactly 2. That's is different from what you know. All right. Let's go to the next one. If 2 or more defective HD TVs, okay, this is when, if 2 or more are found. See, the first one was exactly 2 are found. But this one, if 2 or more are found, then the whole batch will be rejected. That's not good. In other words, if you get 2, 3, 4, because remember the total is 4, then you will reject the entire batch. The manager wants to know the chances of rejecting the entire batch if in fact the batch has 20% defective items. So what are you calculating? We are looking at those we are going to reject, but then we only reject when you have 2 or more. So it means that you got to calculate, watch my hands here, the probability that X is greater than or equal to 2. Now why? Because 2 is part of it. It says 2 or more. So 2 is part of it. Which other number is part of it? Apart from 2. Which other number? Godwin.
3.
Which other one apart from 3?
4.
Which other one apart from 4? Godwin.
That's it.
Exactly, that's all. I just want to be sure that you guys are not just saying 2, 3, 4 and going like that. Okay. So that's how you write this probability. Now watch it. This is very important. So what this means is that we got to find the probability that this is equal to the probability that X is actually 2. Then add that to the probability that X is actually 3. Add that to the probability that X is actually 4. That's it. And that will take a very long time too. But you know that the sum of probability is equal to what number? The sum of probability is equal to what number?
1.
1. So this is the same as saying that you have 1 minus those below the 2. See, we are going the inverse. If it is 2 and above, then it's going to be 1 minus the probability that X is less than 2. because the previous one was less or equal to, sorry, greater than or equal to. So the 2 was part of the previous one. But this one, because the 2 is not going to be part, you have to make it less than 2. Or if you like, you make it less or equal to 1. That's what another way you can do it. So this one, it gives you a shorter distance. Why? Because this is the same as finding 1 and then subtracting the probability of x being equal to 0. Because below 2 means you have to deal with 0 first. Plus, you also get the probability of x being equal to 1. That's it. So you get these two, add them and subtract them from 1, and you arrive at the same answer as the one going to do all of those previous calculations. Guys, do you understand? Very important. Okay. So for me, this is important. This is how you got to know it. So now we have to find the probability of x equal to 0. And when I give you the information, you will notice that that's exactly this. The probability of x equal to 0. So that's it here. The order I said here. Okay. 1 minus the probability that x is less or equal to 1. So you got to find probability of x equal to 0, add that to the probability of x equal to 1, then you subtract both from the probability from 1. That will give you 18%. So the chances, okay, that 2 or more items are going to be defective is just 18% chance, which means that there's not going to be much defective items in the company. Now, the last one. The last one, I've highlighted it here. Find the probability of less than 2 defectives. So you see, now, less than 2 defectives. What is that? Well, first of all, you got to know, we just calculated 2 defectives, isn't it? Well, we didn't calculate 2 defectives. I mean, we calculated it earlier, but we calculated 2 or more defective right now. So if you want to have less than 2 defectives, it means that we are just looking at below 2. Less than 2 means we are only dealing with 0 and 1. It's the same thing as we have done. Same thing. I mean, if you understand the principle, you will note that that's it. It's the opposite. So less than 2 means that we should do 2 and 1. Now the previous one, we use that, we should do 0 and 1. The previous one, we use that 0 and 1, all right, but we just subtracted it to get above. Now here, we are not subtracting because we want them themselves. And that gives you 81.92%, which is the opposite of 18.09. That is how. So first one, we looked at 2 or more defectives. And now we looked at less than 2 defectives. Okay. So those are some ways, but you will notice that the most important thing about this is for you to determine whether it's binomial or Poisson. You got to justify that practically. That's key. That's key. Now, binomial is a distribution. Remember, a random variable can be a discrete number or a continuous number. Any number, any distribution of a number, okay, you can find the mean and then the variance, always. You can find the mean and the standard deviation. And the standard deviation is just the variance, the square root of the variance. So what is the mean of the Poisson distribution? The mean is, sorry, I made a typo, say binomial. The mean is, am I showing the, sorry, the probability binomial distribution. The mean is just the sample size multiplied by the probability. Take note. Okay. The sample size here multiplied by the probability. That's simply the mean. That's also called expected value. And the variance, and of course the standard deviation, which is the square root of variance, is just that same number, which is the mean, multiplied by the other probability. The mean multiplied by the other probability. So just take note of this one. Sometimes after you've done everything, then you are told to find the mean and then the variance. But you already have all the numbers. So the previous one that we just did, n was 4. Probability of success was p, which is 0.2. So you're just going to do 0.4, 4 times 0.2. You put the answer down, very quick. Okay, any question? Let's take one example. You can always find multiple examples around. Okay. So if you have, here there's information has been given to us. N has been given to us here. P has been given us 0.1. X has been given us 1. So if you want to find the mean, it's just 0.1 times 5, which is 0.5. The next thing is to find the standard deviation, which is the square root of the mean multiplied by the other bit of the probability. And then, of course, you can find another one if they change. Okay? If they change, the standard deviation will be different from this one. And you can draw both of them. Okay? How the distribution, remember this is binomial. So the options are just 1, 0, 1, presence and absence, presence and absence, presence and absence. Like that. Okay, so that was a bit of binomial that we looked at. That was a bit of the binomial distribution that we looked at the last time. All right, so we're going to continue and look at Poisson distribution. The main thing that you should know about Poisson distribution is that it's not the same exactly as binomial. You see, whereas binomial is looking at exact probability, so it will tell you the exact probability. The Poisson will tell you the probability based on the average. So it will not give you the probability, it will give you the average probability. Because Poisson deals with, it has some exponential distributions in there. And so it's not like boom, boom, 0, 1, binary like binomial has. And so the distribution is average probability distribution. And you have an example here because certain things have continuous interval, like time. So when you take, for example, football match, you know that the football match has an average time of what? Elisa?
90 minutes.
Exactly, it's so clear. So when you say that a goal was scored in the football match, you are actually saying that a goal was scored in the football match that lasts for that 90 minutes. So how many goals do you think will be scored or were scored, blah, blah, blah. So that's it. You have it. It's based on time. And then you can have the surface area of a place. You can have the length of something. For example, the number of arrivals in a shop in 1 hour. You see, I didn't say in a shop and leave it there. He said within an hour, how many people arrive in the shop? So now you are finding the number of people in the shop based on the average time period of 1 hour. So whatever you find is the average. It's representing only the number in an hour. Okay. You can talk about arrival at a bank cash machine. Like you want to check whether people use the cash machine. So you monitor. And then based on that, you will know how many people use the place every hour. That's really cool. So I wanted to look at Poisson from the perspective of average probability. Now, the probability of the occurrence of the event is constant. It's so constant in Poisson. So if the probability of the event is 0.8, it's 0.8 throughout. The 90 minutes is always 90 minutes. There can be no more than one occurrence. So it must happen. And they don't depend on each other. They don't depend on it. These are just some basic assumptions underlining the Poisson. Please note, I've said it, that the average or the mean is actually represented by this parameter, lambda. That's the mean or Poisson. Okay. And it tells you the average number of successes. You see, the binomial was telling you the number of successes. But this one is telling you the average number of successes, given the space and time. Right. Now, let's take a couple of practicalities here. There is a Poisson formula, just like there's a binomial formula. Please write this down. Memorize if you have to. This is a Poisson formula. We're going to explain it, so write it down first. Write it down first.
So it's 1.2.
Wow. Was it Elias who spoke?
No, sir. I got 0.075.
I like that. Yeah. Let's
It's 2.5.
Exactly. And this is how he got the 2.5. If you multiply the 0.5% by the 500 consignments, see, we know that 0.5% of the phones will be faulty. What we don't know is how many phones there are. And now, we are told clearly how many phones there are. And so we just take the rest. And that is 2.5. That's the lambda, 2.5. Now that you have the 2.5, prove the probability that out of that consignment, none of them will be faulty. Substitute into the probability formula. And let's look at the A part. None will be faulty. Remember that formula is very simple. Let me know when you're done. Who has gotten something? If you substitute well, yes, Eric.
Sir, please, I am getting 0.082.
0.082. Correct. That is what you have here. 0.082. That is it. So the chances of you getting none of them to be faulty is quite slim, which means that Samsung Ghana has got a high probability of not getting faulty phones. Well, sorry. Yeah. I mean, a very low probability of not getting faulty phones, and therefore has a high probability of getting faulty. Just, it's like 0.8%. 0.8%. Okay, what about more than 3 are faulty? Well, it's very simple. You have to first draw the link first. How many are the phones? How many are the phones? You're looking at the probability that X is greater than 3. So that means that you have to calculate that X is 4, X is 5, X is 6, all the way up to 500, because there are 500 phones. By the time you finish, your brother has delivered. So what you do is that you remember the principle that of the inverse or reverse probability. So this will be equal to 1 minus what? Who can tell? 1 minus the probability that Agnes.
Probability that X is equal to 0 is equal to 1, and then
Okay. So you calculate the probability that X equal to 0, which is what we have found already from this question. Probability that X is 1, you subtract all of these from 1. So you do probability that X is 2. Then you do the probability that X is 3. And then once you got this, you subtract them. Because remember, I included 3 because he said more than 3. If he has said 3 or more, that's different. So once you understand it like this, the rest is just calculate. As for the first one, like I said, you've already calculated it. Okay. So this is how you would have done it. Look at the last bit. Look at the last bit here. The last bit is just doing 1 minus the earlier ones. So 1 minus the probability that X is 0, that's this one here. X is 1, X is 2, X is 3. Then you subtract them from 1, and that will give you 24%. So the chances of you getting more than 3 faulty phones is very, very slim. Okay. Calculating it is not difficult. What is difficult might be your ability to dictate that is binomial or Poisson. Let's go to the next one. Suppose that the number of customers arriving each hour at the only checkout counter in a local pharmacy is approximately distributed with an expected arrival rate of 20 customers per hour. Is this binomial or Poisson, and why? You can tell us. Godwin.
It's Poisson.
Why?
Because of the customers per hour, that's per hour.
Yeah, there's another clue. Who has seen the other clue? There's another clue that tells you that this one is Poisson. Patience.
Just trying. The word rate, arrival rate.
That's it. It's the one. It gives you what impression? What impression does it give you?
That we are finding an average.
Thank you. That's it. Perfect answer. All right. So now that we know it's Poisson, we can proceed. Find the probability that exactly 10 customers arrive at this checkout counter. So in Poisson here, all we need is the mean. So what is the mean here? In this question, what's the mean? Esther?
20.
20. Yeah, that's correct. The mean is 20. Now, what is the x in the question? What is the value of x? Esther?
I didn't bring my hand down, sorry.
I could have still said it actually. X is 10. S is 10. So we're going to find exactly, so probability that, I just find the probability that x is equal to 10. That's all. Given the mean. If you do that well, we're going to get this sort of answers here. So probability that x is equal to 10, that's it. Get 0.0058. This is your answer. That's it. I'm done with Poisson. Okay. What do you now recognize as the difference between binomial and Poisson? Can somebody tell me? What do you now see as the difference between binomial and Poisson? I'm going to be calling some of you without your knowledge, to be sure that some of you are not just sleeping. What's the main difference between binomial and Poisson? Let me call Priscilla Bobite. Priscilla, are you here?
Yes, sir.
Tell us.
And with the binomial, there are two outcomes. And then with the Poisson, there can be no more than one outcome.
Okay. But there's something special, unique between them. Who can tell us? Let me go to there's something special. Okay, raise your hand. Amisa, Abigail. Abigail.
Sir.
Go ahead.
Sir, please, I think that with the Poisson, you're always having to find the average of something. And then with the Poisson, with the binomial, it has to do with either it is this or that.
Correct. That's it. Poisson only looks at the average. Very good. So you see, you need the answer. You're hiding. You're not talking. And you delay us.
I wasn't sorry.
You aren't sure.
Sorry.
Let's go to the last one for today. which is normal distribution. The normal distribution is a continuous distribution. It's well known. It's popular. Today we are going to look at it. There are so many things in the world that exhibit normal distribution. So many. So many.
Hello, sir.
Yes.
Can you please go back to the slide before this? I would like some clarification.
This one?
No, where we had the, yes. So I wanted to find out, is there the likelihood of being, I'm looking at the question A. Would there be a situation where you are asked to find that the probability is exactly 10 customers when it's a Poisson situation or circumstance? When the situation given is Poisson.
Yeah, but towards the end, watch it. Towards the end, it says at this checkout counter in an hour.
Yeah, so without that part of the statement, then you are required to use the binomial formula.
No, you can't.
You can't.
No.
Oh, yeah. So I was just thinking, I just wanted to know if that is possible.
All right.
Thank you.
Certain things are normally distributed. The time needed to complete a task, your age, your height, your weight, all of these are normally distributed. The temperature of a solution, normally distributed. Look, one thing about continuous random variables is that continuous random variables can take on any value. They can take decimals, any value at all. And the distributional function, the probability distribution, I've already told you that the distribution is dealing with the entire spread as well as the location. So you can have a distribution which is for one time, and you can also have a cumulative distribution, which is an added one. So watch this one on this section here. The probability of X is, the probability of X is less than a particular number. Now, if we let A and B be those possible numbers, okay, then the probability of X will lie between A and B. And this is how we show it, that the probability of something is lying between this and that. Continuous probability distribution, they always have this situation around. But just know the difference between continuous as well as discrete. All right. The density function of a probability, a continuous, random variable, is what you have down here. Some of you don't like it, so I won't show you. But this is the function. It is this function that we have simplified, and you see the simplification very soon. We made it very, very simple. It's the density. How dense? Normal distribution, the curve looks like this, like bell shape. So the density, so another one can go this way. There can be several different ones. And the peak will show the level of the density. So if majority of the information, the data is in the middle, that is when you see the peak goes up in the middle. All right. But that's not really the complex thing that I'm interested in. I'm not interested in that. What I'm interested in for you today and the normal distribution is to measure the area under the bell-shaped curve. Guys, for your information, write this down. The area under the bell-shaped curve is 100% or 1. Write it down. Write it down. So If the area under the curve is, and please note this because this is a little bit tricky. If the area under the curve is 1, then I can just slice a portion of any part of the curve, the area, and I can ask you to tell me what is that. The area under the curve is also the probability. The area under the curve is the probability. Take note. So, how do you read the area under the curve? Guys, monitor this. The center is always the mean. The center of the kernel density function, which is also called the normal probability density function. The center, which you see here as a peak, this line, this center here, that center is the mean. And the movement from the center is to the left going this way and to the right going rightwards here. So anytime you want to look at an area, you measure the area from the center going left and from the center going right. Remember, going left or going right itself shows a deviation from the center. It shows a deviation from the center. Our goal is to find the area. But please note, if the center here, the whole of this area, this whole area, if it is 1, then half of the area is what? This section here is what? 50%. And that section here is also 50%. And so keep that in mind. And the whole area is 100% or 1. Keep that a lot. Our goal is to find the area under the normal curve. So how do you find the area under the normal curve? Guys, follow me. I've already told you that the entire area is made up of 1. And we can portion any portion. This is a normal distribution. It's called a bell-shaped curve. It's very symmetrical. So when you're in the center, you are halfway from every portion. The mean, the median are equal at the center. So at the center, the mean, the median, and all of them are constant. The spread, which is the standard deviation, sometimes it can be the variance, is determined by that sigma value. And we've said that the random variable has a theoretical range. So when you are in the center going leftward, you're going leftward to infinity, negative infinity, and you're going rightward to positive infinity. So keep that in mind. We are just trying to find some characteristics before we start. If you can find the characteristics, you can also do anything else. All right. So you can see that there are different parameters of the mean and the variance. There are different parameters of the mean. Just the different parameters of the mean and then the variance. That's all you needed. Okay. So let's take a couple of examples to make it. This is the easiest one, by the way. Now, the formula for the normal probability density function is what is here. Don't bother yourself with it. Just know that you learned something. You know, sometimes in life, you have to go home and tell your parents that, look, I've learned something. This is what I've learned. They ask you, what have you learned? Then you said, I have learned the normal probability density function, which is f of x, which is equal to 1 over the square root of 2 pi sigma 2. Okay, raised to the power, the natural log, the base of the natural log, you know, to the power negative x minus u, all closed brackets, divided by 2 sigma squared. By the time you finish, your parents can then clap for you. I mean, you got to learn something one day so that you use it to to let people know that you are learning. But I will never ask you to give me this. Okay. Our goal is to find the area. Never forget it. Our goal is to find the area. So watch it. If you look at the area I've shaded blue here and red, the question to you is, how do you find the area? This is how you find the area. You always move from the center, then you get to the right, or you move from the center and then go to the left. So it's from the center to the right, center to the left. But if you look at the area, watch it carefully. I'm not looking for all of the area. I'm looking for the red and the blue. But then the red is inside half of the area, and the blue is also inside half of the area. So how do I get the distance from A to B? How do I get it? Well, I know that the left part is 0.5. So what I need to do is to calculate A. Now, when I say A, it means I'm moving from the center to the left towards A. So I got to calculate the probability for A. I got to calculate the probability for A. Follow me here. Remember, there is a random variable called A. I need to now go and get a probability for it. But I cannot get a probability for it unless I get a Z value for it. And I'll come back to that. So you can see that the X, the red area, the only way I can find out a red area is to find the Z value in that direction. Please take notes. If you don't take notes, you might miss it. In the direction of moving from the center to the left. That's because I'm looking for the red area. If I was looking for the area here, what I need to do is to rather find the red area and subtract it from 0.5 to get a white area. But because the movement is always starting from the center going left or center going right, if I have to find the blue area, I will just go and find the Z value for B, and then read it from the probability table. And then after that, that will give me the blue area. Remember, the probability is the area. That will give you the blue area. So we are going to do a couple of these things to get an understanding of that. There are several areas that you have to find. The most important thing is that you just learn how to draw and indicate the area you are looking for. Let's take, for example, this one's here. Let's take the first one. So the first one is saying that let us look at it here. Let us find a number. So I can say that let us find probability that X is less than 50. Okay. Meanwhile, the mean is 40. The mu is actually 40. And then we can say that let's find the probability that a particular random variable is rather less than 50. Less than 50 means that it should go above the 40, which is the mean. So your area you are looking for should be above the 40, where the mean is 40 here. And we are looking for any area below 50. So you have to shade the entire left of the area you have identified as 50. This is important. You will have to draw. Without drawing, you are failed. So you got to learn to draw. Okay. And how do you get this area? As you can see here, we already know that half of the area that is shaded is what number? Half of the area that is shaded is what number?
40.
No, half of the area.
20, sir.
No, half of the area that is shaded, that is from this black side towards this left side. All of that shaded area, what is that? Magdalene.
50.
It's not 50.
30. 30.
It's not 30.
30.
It's 20.
It's not 20.
No, it's 50.
It's 30.
You have said a thing, I say it's not 30, it's 30. It's 30. It's 30. You are insisting.
25.
Don't guess. Stop guessing. You are killing your head.
Yeah, please, it's 50.
It's
You're wrong.
50.
I told you that the entire
50%.
area is 1. So half of that area is 0.5.
But so you said 100, 100 or 1.
And so when you say 50, you haven't spoken, unless you say 50%.
Sorry, 50%.
Look at you. You have to be very clear here. You know, we are not guessing, because especially when somebody even went to say 30, it confuses even you when you add 50 without adding, if you knew it was percent. If the entire area, please, I never said the entire area is 100. I never said it. I said the entire area is 100%. I never said it's 100.
Apologies.
It's different 2 ways. Okay, 2 different ways. So the entire area is 1. Half of it is 0.5. So you already know that what you've shaded, half of it is 0.5. What you need to now do is to just find this smaller area, which will be direct movement from the center to the right. Once you find that, you don't need to subtract that from anything or add that to 0.5, because it has given you the area directly from you all the way to B. So let's say that you found that and it was 0.25. Then it means that this shaded area is going to simply be the 0.5 plus the 0.25, giving you 0.75 or 75%. So that shaded area is what we are going to find. And that area is known as the probability, which is between 0 and 1. Now let's look at the second area. The second, we are still using 40 here. Okay. So the second area is not here, which you have to pass before you get to the area itself. It's rather, it's like you being asked, find the probability that X is less than 20. You know that 40 is the center, the mean. So 20 will be to the left or to the right. Which one? It's to the left. And because 20 is to the left, that is what I have indicated here as A. And you are being told to find X is less than, I'm just giving you warm up before we come to the realities. How do you find the area below A? The only way you find the area below A is to first find the area up to A. And so the area up to A, the number A is 20. So you got to find the X random variable is 20. You have to find the Z equivalent of that. And that Z equivalent to give you the probability, which is the area you are looking for. But once you have found that, that is not the area you're looking for, because when you look at it, the shaded area is outside the movement of the one that gave you the probability. So let's say that the probability you got was 0.43. That is not what you're looking for. What you're looking for is the one beyond 0.43. So how do you get it? Who can tell me? How do you get the one beyond? You subtract the 0.43, which is the movement from the center to the line here. You subtract that because that's a white area. You subtract that from 0.5 because your mind tells you that the entire half of the area is 0.5. You subtract that from 0.5 and everything else is yours. That's how you find that small area. As for that, it's the last one, we just done it some few minutes ago. So we're going to learn how to find these areas. Okay. Let's take them one by one. So I just had to use some of these things to tell you. Let's take a practical one. I told you that the probability or the area under the curve, we measure it using something, the standard normal variable. And there's a formula for moving from the standard random variable to find the probability or the area under the curve. You have to use something we called the Z formula. It's known as the standard normal variable. And it is the only way that you can use to approximate a standard random variable towards its probability level. This value, this formula here you see on your screen, this one here, it helps you to move from this X variable, passing through the Z variable until you get to the P variable. That's it. So before you find the probability of anything, or the above the probability or below the probability or exactly the probability, you have to find Z first. And the formula, there's a connection between the Z. This is what we call the Gregorian, standard Gaussian distribution. The Gaussian distribution. So let's take an example to see how we can do that movement. This is it. Let's take a typical example, a very simple one. And then we'll be wrapping up today. If the income of Kayayo sellers is normally distributed with a zero mean of 100 and a standard deviation of 50. Remember, the mean and the standard deviation is always given to you. Watch the sentence, the average mean of a normal random variable. And this is a Kayayo. So I go into Makola, pick the Kayayos there, I check their salary. The average income they make is 100. And there's a standard deviation of 50. Okay, now, what is the probability that if I go into the Kayayo market, I close my eyes, I bump my hand to find someone, what are my chances that that person I picked, closing my eye, is rather making 200 cedis instead of the average of 100? Guys, can you draw this? The first thing you need to do to draw this is to write a horizontal line like this, and then draw the normal bell-shaped curve. Indicate the center. And remember that the center is always the mean, the mu, the population. And go to the question, and you will see that the mean has been given to you. In this case, the mean was what? It's 100.
100.
The variance is what? But the standard deviation is 50.
50 cedis.
So you got to write that. You got to write that. Everything on that horizontal line is a random variable, X. So 200 is along that line, but the center is 100. Now, if the center is 100, then the 200, is it to the right of the 100 or below the 100? The 200, is it above or below? It's above. It's above. So now we have to identify any corner here and call it 200, and that's the X value that we're looking for. Now go back to the question. The question says that, what is the probability that if I close my eye and I try to pick anybody who is a Kayayo, what is the probability that that Kayayo person is earning less than $200? Now, which area are we looking for that I have to shade to represent this? Who can tell me? I've labeled the areas. Which area? Godwin.
We'll be shading from B to A. Yeah.
Again, why are you saying A? Why is somebody interrupting you? The person didn't even open the mouth. No, I didn't raise a hand. The person is saying A. Continue. Start again.
Less than 200 will be B and A.
Exactly. That's it. And so if you have shading, you have to shade this area here. And the shading will give you some good marks. So that's it. That's what you shade. So we are looking for that area. We don't need C. How do we find it? Well, the first thing we need to do is, as for A, we know the value already. What is the value?
Yes.
What's the value of A?
0.5.
0.5. So what we need is that of B. That is all we need. And we know that the movement is from the center to the right. So to get a B, we need to approximate. And when I say B, I'm talking about the area. We need to now approximate the value of 200 and take 200 to z-value terms, standard normal distribution terms. How do you do that? Use this formula known as a z formula, which is a x minus mu over sigma. What is the value of x here? It's 200. What is the value of the mean? 100. So you get 200 minus 100 divided by the standard deviation of 40. What do you get? You get a value of 2. And always make it 2 decimals. So it's 2.00. Guys, take your table I gave you. Take your table that I gave you. Open that table that I gave you. So I'm going to go to the table, what you might call a tableau. And on your screen, you see this table. Okay. You see this table. Now, this table is what you use, is a standard normal distribution table. There are different ones, but they all arrive at similar answer. Which are we looking for? We've just calculated the z value, and we just found out that the z value is what number? Do you remember the number?
2, sir.
Good. This was the z value. The number was 2. We are going to read these 2 from the z table. So when you go to the z table, on the far left column, you see that there's a z value there. Okay. Open your eyes. There's a z value there. Now that is where you are going to look for the number. Okay. And you can see that the number keeps going down. You are going to look for 2.00. Always is 2 decimals. 2.00. So as you look through, you will notice that 2.0 is here. The next 0 should be read at the top. The next 0 should be read at the top. And because it's just 2.00, you cannot go and use 0.01 or 0.02 or 0.03 or 0.04. It has to be 0.00. And so where that 0.00 meets the 2.0, where they meet, this one is coming down, this one is going rightward. Where they meet, that is your z value. So ladies and gentlemen, what is our z value?
0.477.
4772.
Correct. That is our z value.
Sir,
Yeah.
can you please go over that again?
What you do is that once you know the z value, you come here and then come and identify that z. The column is z. You look for the number. The number is always supposed to be in 2 decimals. In our case, the number was 2, and then we made it 2 decimals, so you got 0, 0. So you got to first come and look for the 2. Here you have 0.1, 0.2, 0.3, 1, 1.2, and then finally you get to 2. Now, if it has been 2.03, okay, I would have done 2.0 and then 3. I'll come and pick the 3 here. But this one, it was 2.00, so I'll come and pick the 00 here. And where the 2.000, where this vertical and this horizontal meet, you see this point, you are coming down, and then the one here is going rightward. Where they meet, that is the value of the probability. So we have gotten the probability to be 0.4772. Now, how do you now write it? Well, you have to understand what the question was saying. It says less than. So what we have actually found, okay, we have actually found this area, the B area. That's what we found. And what was the value that we found? We found that value to be 0.4772. But is that all? Is that the only thing we are looking for? No. We need to add 0.5 to it. Because remember, it was this whole area. That's all we're looking for. So you add 0.5 to that. And that gives you 0.9772. How do you write it? It's a very simple thing, but it's a very also interesting thing. Okay, this is how you write it. You write that the probability that Z, okay, the probability that Z is less than 2, which I would have actually written it as probability that X is less than 200. That is also the same as the probability that the Z is less than 2, because we found this using that. And this will be equal to the 0.5, which we know is already that area, plus the 0.477. And that gives you 97.72%. So the area, the chances of you getting a Kayayo, now let's interpret it. The chances of you getting a Kayayo who is earning 200 or less is very high. It's very high. It's very high. And that is what we just found. Any question? So the entire area we've been looking for all along was rather 97.72. Ladies and gentlemen, you need to be able to learn how to do these calculations, especially how to draw, because it's only when you are learning how to draw that you can find the rest. Remember that the total area under the normal curve is always 1. And so it's a matter of breaking things down and finding that one. Let's take another one. And that will be it for today. Next time we'll look at the complexities of it. Suppose X is normal with a mean of 8 and a standard deviation of 5. You have to draw that first before you even look at the other things. So the mean of 8. So again, you write this horizontal line, you show your normal distribution, you show the mean, which is a center. You write mean of 8. The standard deviation is 5. You just put it under it. Okay. Now what's next? The next thing to do is to identify the question. The question says find 8.6. X is less than 8.6. I think this one is cheap because it's just like the one we did. Okay. Find X is less than 8.6. X is being less than 8.6 is not. So you just identify if the mean is 8 in here. I can point out anywhere here. Okay. Anywhere there as my 8.6. And then shade this left side because this is everywhere below 8.6. Remember, the symbol there was less than. So that is why I'm using less than 8.6. Okay. And again, once you get that, you just have to go and then put it into the Z formula. The Z formula is X minus mu. In this case, the X is 8.6. So you do 8.6 minus the mu. What is the mu here? 8. Divide that by 5. Then you get the answer. Then you can substitute that into the Z formula. Okay. That will be it. Let's move on. So, as you can see from here, we can find distance easily, just as we did the previous one, because it's just coincidental. And then you can find what is below. The Z value is 0.12. So you go to the table. And then 0.12 is this. 1.12, so it's 0.1 here. Then under 2. You read it here, 0.0476. Point one, 2. That's it. You get 0.04578. So that is how it's supposed to be. Once you read this, you come to the work, and you can see that you have to add 0.5 to the answer. That's it. You add 0.5 to the answer, and then you can now get 0.5478 here. And you can do above. If you are supposed to do above, the above is going to be this. Okay, you're just going to shade the right-hand side above 0.8. So in this case, you're looking for that. So whatever you found previously, okay, which is 0.0478, that one will rather give you the white space from the center to the right, from the center to the right. So you just subtract that from 5.5, and that will give you the red area here. Okay. Just do that. So that is how you do most of them, and you can see it here. If you subtract from 0.5, you get it. Okay. And you'll get the same answer, which is 0.4522. So that is how you do all of those things. Solve as many examples as you can from the document, and you will crack all of this. So ladies and gentlemen, that brings us to the end of our study. Next time, we will see how to switch from the individual to the we have just seen how to move from X and use the X to find the Z and use the Z to find the probability. Now, next time we'll just move it backwards slightly. If I've given you the probability, how do you find the Z? How do you find the X? It's very simple. Very, very simple. Any question, please? Any question? Right. So, ladies and gentlemen, that brings us, yes, Patience. Patience, your hand is up.
Yes, I have a question, but not on this.
Okay, hold on.
Okay.
Hold on.